It was Lemon that first drew attention. A bright green flare in the sky, unlike anything seen in months. Then came Swan, trailing close behind, bursting with volatile jets and a shifting blue-green glow. The spectacle of two comets racing across the night sky on the same evening was already extraordinary. But what truly startled astronomers was what formed between them, a faint but detectable plasma bridge. This wasn't just a coincidence or a scenic sky-watching event. It was the first time scientists had suspected a direct electrical interaction between two cometary bodies, millions of miles apart. The discovery hinted at forces we've barely begun to understand, electric and magnetic dynamics shaping the behavior of objects at the edge of our solar system. If you're still watching, subscribe now. You crave more than answers. You seek what lies beyond. Subscribe now and be part of the few who never stop searching. Beyond their visual brilliance and synchronized motion, Lemon and Swan brought something even more profound, material from the dawn of our cosmic history. Both comets carried unusually high levels of organic molecules like cyanogen and hydrogen cyanide, substances linked to the chemistry that may have seeded life on Earth. Their arrival wasn't just a beautiful moment. It was a glimpse into the universe's ancient past and a reminder that space is not a silent void, but a living, dynamic environment. The trails they left, and the microscopic debris that entered our atmosphere, connected us tangibly and symbolically to the broader story of existence. Last night, the sky above Earth told a story older than time. Two comets, Saltas 2025 A6, Lemon and Sipun's 2025 R2 Swan, passed by our planet in a rare synchronized display that captured the attention of astronomers across the globe. Both came from the far reaches of our solar system. Both arrived at nearly the same moment. And both left behind questions that may take decades to answer. This wasn't just a beautiful sight, it was an anomaly. A moment in cosmic history that scientists will dissect frame by frame, because this wasn't just two icy bodies passing through. This was activity, this was interaction. And in the depths of space, interaction means energy. These comets didn't just glow, they pulsed, their brightness fluctuated in patterns too coordinated to ignore. Scientists initially pointed to solar wind as the likely cause, but that explanation didn't go far enough. Because something else was happening, something much stranger. Between the two comets, sensors picked up what may be the first observed plasma bridge ever recorded in open space. A possible connection between their electrically charged tails stretching across millions of miles, not a gravitational pull, not a fluke, but a visible interaction. Two celestial bodies, millions of miles apart, forming what may be an electrical link across the vacuum. That phenomenon alone would have made the night historic, but it didn't stop there. Both Lemon and Swan were carrying something rare, elevated levels of organic compounds, cyanogen and hydrogen cyanide. These aren't just chemicals, these are molecular footprints, traces of the same elements believed to be foundational in the origin of life. And they weren't just present, they were abundant. That alone reframes the discussion, because it reinforces a possibility. Scientists have long considered that the building blocks of life didn't start on Earth, they were delivered to it. Icy messengers from the early solar system, preserving ancient material from an era before Earth had oceans, before it had an atmosphere, before it had life. Lemon, discovered in January 2025, displayed a green coma, a halo of light caused by diatomic carbon molecules reacting to ultraviolet radiation from the sun. It was bright, stable, consistent. A classic long-period comet with a clear symmetrical shape. Swan, discovered in September of the same year, was different. More erratic, more volatile. It had survived a dangerously close approach to the sun, a brush with solar fury that left it scarred but active. Its blue-green glow revealed violent jet activity as it released gas and dust in sudden bursts. The contrast between the two couldn't be more striking. One calm, one volatile, both behaving in ways that defied easy explanation. Their proximity to Earth, 56 million miles for Lemon, 24 million miles for Swan, put them close enough for advanced instruments to observe every detail of their interaction. Those distances may seem vast, but in astronomical terms, they're close, uncomfortably close. Especially when both arrive on the same night. That timing raised a bigger question. Why now? The leading theory points toward the Oort cloud, a theoretical shell of icy debris encircling our solar system far beyond Pluto, It's believed to be a reservoir of long-period comets, dormant and undisturbed for billions of years, but something disturbed it. Something triggered movement, a gravitational nudge from a passing star, a collision, even the subtle influence of an interstellar object sweeping through deep space. Whatever the cause, it set two comets on a course that brought them to Earth's neighborhood, within hours of each other. The statistical odds of such an encounter, slim. Two comets, originating from the same distant cloud, reaching Earth's vicinity at the same time and displaying synchronized activity. That's not normal. That's not expected. That's the kind of anomaly that redefines models. And while the visual display dominated headlines, something more subtle happened that night. Microscopic fragments of cometary dust entered Earth's atmosphere. Not enough to be dangerous, but enough to matter, enough to study. That dust isn't just debris, it's ancient, older than Earth, containing isotopes and material untouched since the birth of the solar system, and now it's part of Earth's upper atmosphere. That connection matters because it proves something scientists have always theorized but rarely observed directly, that Earth isn't isolated. It's constantly exchanging material with space. The boundaries between planet and cosmos are more porous than they seem. That dust is evidence, proof of Earth's ongoing exposure to the universe's raw material. It carries signatures, chemical fingerprints, that can be studied, cataloged, compared. It's the kind of data that helps researchers trace the origin of organic molecules, track the history of cometary evolution, and explore how life's ingredients travel through space. The events of that night weren't random, and they weren't just pretty. They were a scientific milestone, a confirmation that our solar system is still dynamic, still active, still throwing surprises at us. And it gets stranger. The synchronized brightness patterns between Lemon and Swan weren't subtle. They tracked with solar wind activity at first, but their mirroring behavior lasted longer than expected. That forced scientists to question if something more was occurring, some kind of long-distance electrical or magnetic resonance. The plasma bridge supports that theory. But if confirmed, it would upend current models of comet behavior, because until now, comets were thought to be largely passive, chunks of rock and ice, driven by gravity and solar radiation. This event suggests otherwise. It suggests that comets are capable of active interaction, not just with the sun, but with each other. That they might respond to shared environmental conditions in real time, that they might even influence each other's behavior across vast distances. If true, that changes the way we think about the structure of space. It changes the way we monitor comets, and it raises a deeper, more unsettling question. What else is happening out there that we've never noticed? The implications extend beyond astronomy, because anytime organic molecules are found on a celestial body, especially ones as ancient as these, it adds weight to the panspermia theory. The idea that life didn't originate on Earth, but was seeded here from space, delivered by comets, preserved in the ice and dust of bodies like Lemon and Swan. These weren't dead rocks, they were time capsules, and they spoke just briefly, as they passed. There's no evidence that this was more than coincidence. No proof that the synchronized arrival of two comets, with active organic chemistry and a possible plasma bridge, was anything but chance. But coincidence on this scale feels like something more. It hints at orchestration, or at the very least, an unseen rhythm in the movements of the outer solar system. A deeper logic we don't yet understand, and it forces us to consider the Oort cloud, not as a static junkyard, but as a living boundary. A place where things happen, where objects wait, where disturbances ripple across eons before making their way toward us. In the coming months, researchers will dig through the data, they'll model the plasma bridge, they'll analyze the organic material, they'll study the dust, but the broader takeaway is already clear. The solar system isn't a finished story, it's active, unfolding, shifting. Events like this remind us that space is not silent, that celestial bodies are not inert, that the universe is far from empty. Two comets passed Earth last night, that's the headline, but beneath it lies something more important. They spoke of origins, they carried the past, they interacted in a way we've never seen before, and they left behind a trail of evidence, dust in the atmosphere, data on our instruments, and questions that might never be fully answered. This wasn't just a spectacle, it was a message. We just haven't figured out what it says yet. If you're as captivated by these celestial mysteries as we are, help us keep exploring. Like the video, share it with someone who still looks up at the stars. Drop your thoughts in the comments. What do you think this encounter means? And don't forget to subscribe for more stories that bring you closer to the hidden forces shaping our universe. For a few hours last night, Earth sat on the edge of something ancient. Two comets, born in the icy darkness beyond Pluto, traveled billions of miles and crossed paths just close enough for us to notice. Just close enough to remind us how small we are, just close enough to shake the scientific world without making a sound. SIT 2025 A6 Lemon and SIX 2025 R2, Swan didn't ask for attention, they earned it. They arrived quietly, but left behind evidence that may change how we understand cometary behavior, deep space chemistry, and even the origins of life itself. No one predicted they'd interact, that part wasn't in the models. Two comets making a close approach to Earth on the same night is rare enough, but for them to show synchronized brightness patterns, that's beyond rare, that's uncharted territory. And when instruments picked up signs of a plasma bridge, an actual electrical connection, it sent a jolt through the scientific community. Not because the theory was new, but because no one had ever seen it before. A plasma bridge isn't something you can explain away easily. You don't just get one by chance. It requires two electrically charged bodies, both active, both interacting with the solar wind, and aligned just right. In other words, everything had to go perfectly wrong, or perfectly right, for this to happen. The bridge wasn't just theoretical. Observations confirmed fluctuations in the ionized gases surrounding both comets. That's the tail end of plasma behavior, literally. Their tails, composed of ionized particles, didn't just flow in the same direction, they resonated. They pulsed, and the pulses lined up. This is where science gets uncomfortable, because when two bodies millions of miles apart begin reacting to each other in real time, it opens the door to theories most researchers prefer to avoid. Electrical interaction at that distance isn't supposed to happen, not like this, not visibly, and certainly not in sync. For decades, comets were categorized as inert space debris, frozen leftovers from planetary formation, but last night, that definition cracked. Lemon and Swan weren't dead, they were alive with activity, with organic molecules, with behavior. Their synchronized passage wasn't just an optical phenomenon, it was an event. Let's talk about those organic molecules. Cyanogen and hydrogen cyanide, both found in elevated quantities in these comets, aren't just random chemicals, they're precursors. Compounds that, under the right conditions, can lead to the formation of amino acids, and from there, life. We've seen these molecules in comets before, but not like this, not in this quantity, not in two separate bodies appearing simultaneously, interacting and carrying these exact compounds. That alone is enough to reframe cometary science, because if comets really are delivery vehicles for life-essential molecules, and if they can survive a trip through the solar system while interacting electrically, then they're far more complex than we've been willing to admit. This event didn't just confirm that theory, it shouted it. Lemon, with its steady green glow, told one part of the story. Its coma, a glowing envelope of gas surrounding its nucleus, lit up due to the presence of diatomic carbon. When that carbon was exposed to ultraviolet light from the sun, it fluoresced. It was a slow, beautiful reaction, textbook behavior. Then came Swan, different in almost every way, newly discovered. Violent, unstable, its close approach to the sun had pushed it to the edge. As it whipped around, the heat ignited volatile compounds inside its core, causing sudden outbursts. Jets of gas and dust exploded from its surface, releasing more organic material into space. One comet was calm, the other was wild, yet both responded to the sun, and possibly to each other, in nearly identical ways. That symmetry has no precedent. It's not a coincidence you can easily explain, and maybe that's the most haunting part of this entire night, because nothing in our models predicted this level of coordination. Nothing suggested that two comets discovered months apart, following different paths, would show up on the same night, within visual range of Earth, and perform like a binary system. But there they were. Their origins are still being studied, but early data points toward the Oort cloud, a vast spherical halo of icy objects surrounding the solar system. It's where long-period comets are believed to originate. It's remote, frozen, largely uncharted, and something disturbed it. Maybe a passing star, maybe a rogue planet, or interstellar object. Whatever it was, it triggered movement, set objects in motion. Some of those objects collided, others shifted orbit, and Lemon and Swan began their long journey toward the inner solar system. The idea that these two comets were knocked loose at the same time, from the same region, isn't just possible, it's likely. And if so, that means this event was set in motion millions of years ago, a chain reaction in the frozen dark, invisible until now. They crossed paths with Earth last night, but their story started long before humanity ever lit a fire. As they passed, they shed more than gas and dust. They released material never before exposed to light. Ancient carbon, frozen molecules, preserved from a time when the sun was young, and some of that material, microscopic, barely measurable, entered our atmosphere. It wasn't a meteor shower, no fiery spectacle, just specks. Particles drifting down through the sky, invisible to the naked eye, but they matter, because inside that dust are isotopes that can't be found on Earth, traces of environments that haven't existed here for billions of years, data points from the solar system's forgotten past. They're in our atmosphere now, being collected, being studied, and what they tell us could reshape theories about Earth's early chemistry. This is what space science looks like in the 21st century. Not just telescopes and predictions, but live, unfolding data, real-time surprises, and constant recalibration of what we thought we knew. No one expected a plasma bridge, no one expected synchronized emissions of organic material, and no one expected the kind of dual comet interaction we just witnessed. But it happened, and now the work begins. Parsing the data, tracing the dust, mapping the trajectories, rethinking the models, because this wasn't just a rare event, it was a call to reconsider what we think comets are. Not relics, not leftovers, not silent, but active players in a dynamic system we barely understand. Vehicles for ancient material, potential carriers of the seeds of life, capable of complex interaction in the void of space, and we got a front row seat. It's over now. Lemon and Swan are already receding into the black, fading into the cosmic background like everything else, but the memory of what they did, and the data they left behind, will echo for years. This is why we watch the skies, because every now and then, something passes by that changes everything, not with noise, not with drama, but with silent, undeniable fact. Two comets, one night, one interaction that rewrote the rules. There's more to come. More discoveries buried in that plasma trail, more evidence in those organic molecules, more truth in that dust, and when the next anomaly comes, because it will, we'll be ready. They're gone now, just fading specks, retreating into the deep, their tails thinning into silence. Lemon and Swan, two ghosts from the edge of the solar system, passed through our corner of the universe, left fingerprints on our atmosphere, and vanished without a trace. But something lingers, not just in the data, not just in the molecules, in the feeling, that eerie sense that we just witnessed something we weren't supposed to see. That maybe for a few short hours, the universe opened a curtain and let us glimpse how alive it really is, because space doesn't usually talk, it doesn't speak in language or light, but last night, it whispered through chemistry and plasma, through synchronized patterns and shared momentum, through two comets flashing with organic potential, and the whisper was clear. You're not alone in this, not in your origins, not in your elements, not in your motion. We're part of something much larger, something moving, something ancient, and every so often we get a reminder that Earth is not the center, but simply one thread in a vast electric web of cosmic events. So don't let this night pass like any other. Talk about it. Wonder about it. Look up. And if you want to keep hearing these stories, these real hard, unbelievable truths hiding in plain sight, then hit like, share this, subscribe, because this isn't the end of the story, it's the beginning of a new question, and the next answer is already on its way. They came from the cold, ancient outskirts of the solar system, and just like that, they vanished. Lemon and Swan have already faded from the night sky, their brilliant tails stretched thin across the dark as they retreat into the void, but what they left behind isn't fading. Not for scientists, not for skywatchers, not for anyone who understands what actually happened last night. We didn't just witness a celestial coincidence,
we witnessed a fracture in what we thought we understood about deep space interactions. These weren't two comets passing silently in the night. They were two active electrically charged bodies exhibiting behaviors that shouldn't be possible, not in theory, and certainly not in practice, because comets aren't supposed to communicate. But if that plasma bridge was real, and all indications point to yes, then the conversation has already begun, and it's being recorded in every sensor log, every spectral analysis, every byte of observational data gathered by telescopes and satellites worldwide. That bridge, however faint, however brief, hints at something more profound than shared origin or coincidental timing. It suggests connection, not just chemical, not just spatial, but electromagnetic. That's interaction on a level that opens doors to questions scientists have avoided because the answers are messy, answers that challenge the boundaries between planetary science, plasma physics, and astrobiology. Because now we know, comets can share energy, they can glow together, burn together, shed molecules together, even from millions of miles apart. That alone means our models are missing something vital, and in those missing pieces, there may be clues about how the early solar system functioned, how organic material moved between bodies, how environments that once seemed sterile might have been active participants in cosmic evolution. We always thought of comets as messengers, but maybe they're more than that. Maybe they're couriers. Maybe they carry not just the ingredients for life, but the instructions, the momentum, the spark, the electrochemical potential. Maybe this is how life travels, not just by chance, but by design embedded in the structure of the universe itself. That sounds like science fiction, until it doesn't. Until you watch two comets born in the same frozen sea of the Oort cloud, cross Earth skies together, flare in sync, and throw a glowing arc of plasma across space. Then it becomes something else entirely. Call it timing, call it physics, call it an accident, but don't call it meaningless, because nothing about last night was meaningless. And if you're still with us, still thinking about what this means, still staring up, wondering what else might be out there, then don't stop. This is how discovery begins, with questions, with doubt, with awe. Like this video, share it with someone who still believes in asking why. Leave a comment. What do you think these comets were trying to show us? And subscribe for more, because we're watching the sky, and it's watching back.